Hey everyone. Now if you've been watching my videos lately, you'll see I've been playing with IPv6 a lot. And one thing I've been reading up on is the hesitancy to go to IPv6 is because of this notion that IPv4, when it has NATing, is like an inherent firewall. Well, I'm going to show you today that NAT is not a firewall. So I've got a few Raspberry Pis here that I'm going to use as props. So I'll just show you what I've got set up here. Right, so over here is the computer I'm going to use for a desktop, which is this one here on the screen. That's just going to be like a normal home computer that you'd have. This one here is the router, so that's like your home router. And over here is some web server, like a web server on the internet that you might connect to. So home system will go through your router to the internet somewhere. That's going to be the setup here. All right, so I'm not really going to be talking about IPv6, even though a lot of the concepts are the same. Just IPv4, like you'd probably have at home with NAT being done on your router. First of all, I want to show you an image and go through it. All right, this diagram shows the path that packets take through a system. It's common to most systems I know anyway. So I'll just go through this with you. So a packet comes in over here and we have to decide what's going on with it. So the router that I've got, the Raspberry Pi thing here, or your router at home, we'll look at this router here as being this unit here. So when a packet comes in, what happens? Now, the first thing that happens is, let's say you're a home computer down here and your packet, you want to talk to the web interface of your router, for instance. Well, that's an application that's running on the router. So that packet will come in here, go to a routing decision saying, is it for a local process, like its web interface, or is it something that it's got to forward through, be a route out to the net? Now, if you're looking at the web interface locally, that must go here. So then it goes to this input hook. So you can put rules on here. All of these hooks, these green things here that say hook, that's where you can put rules for different things. So on the input hook, you might not want to let things get to the local processes. So you can put firewall stuff on here. If though, you're sending a packet not to a process on the router itself, but you're trying to send something through the router out to the other side, it will come here and it gets to this routing decision and I'll say, well, it's not for a local process, so send it through. Now this forward hook, it will then hit that. So you can have firewall rules there to say what can go through. Now this post routing hook, after it's either come from the local process or some packet that it's forwarding through, as in routing through, you can then do this post routing, and that's when you can do some network address translation, as you can on the pre-routing. So with pre-routing and post-routing hooks, they're for different purposes, as it says here. This source NAT compared to dest NAT is the difference. So let's say you're sending a packet out to the internet and it starts off on your home network and it goes through here, goes to the internet, goes through here. When it hits this post-routing hook, that's when it'll change the source IP address. That's why it's called source NATing. So the post-routing hook, once it's finished all this and knows that it's got to be sent out, the last thing you'll say is, by the way, change my source IP address to be whatever your WAN interface IP address is. And then it goes out. So when it goes out to the internet, some server, and it comes back, they see the address as your WAN interface. And this keeps a track of that. So when it comes back, it goes, that was for me. And it'll come back into your host that instigated the thing. Now, that post-routing hook isn't a firewall. The firewall would be done here. That's when we decide what goes through and what doesn't. So I'll just show you this in practice with these Raspberry Pis here. So on the Raspberry Pi here, that's this computer here. So where it says computer, that's here. And I've just set it up as IP address show dev if1, which is the one I've got connected to this green cable going through here. Forget the 169 stuff. That's what I was mucking around with before. This is the main one here. You can see that's my address. Now that addressing scheme, 10.0.0, whatever, that's what you might have at home. You might also have 192.168 addresses. They're specific addresses for home use that won't appear on the internet. That's so we can use them at home. Okay, now as I said, I've set up a web server on this Raspberry Pi here, and I've got routing through this lot. So I've got no network address translation, just routing enabled. So now I'm going to access this web server. Okay, so I'll go to the web server here and I'll do a packet capture of TCP port 80, because that's what I'll be using, and don't bother resolving any names. Okay, so that's listening on the web for HTTP traffic. So what I'll do now is from this computer back here, I'll access the web server, which is 2.0.0.44. I just put a default web server on there. Okay, so there it is. So what can we see? Well, back here, the source address is 10.0.0.5, which is my desktop here. So it saw 10.0.0.5, it went from the router, went to the web server returned that traffic from it back to 10.0.0.5. Now that doesn't happen on a normal home system because that private address, that 10.0 something address or 192.168 address, whatever you use, when that leaves your router, as shown on the diagram I just showed you before, that last little bit before it goes out, it changes the source address. So it does source NATing. So the WAN web server would only see your internal address. Would only see your WAN address, not your internal address. So what I'll do now is I'll set it up so that this router does the same thing. Right, so here's the router, and I'm going to set up some NF table rules. Well, really one rule. So you can see here, this is my firewall table here for all of iNet. Now, if you had a look back here, you'll see that there's iNet, IP, or IPv6. That simply means IP is IPv4, good old just IP. IPv6 is IPv6 only, or iNet is both. So what I have, and I've always had, is the table is iNet. So this applies to both families of protocols, IPv4 and v6. So anyway, go down here, you'll see all these hooks. So you have a forwarding chain, these are called whatever, input, forward, output, post routing, which may look familiar, pre-routing, forward, input, hook. So the actual hooks for them are written here. So in my chain called post routing, the type is NAT, and the hook is at post routing, which means that's where it's going to take place. Right, so in that, I'm going to say output interface name, and my interface here that hits the WAN is ETH1 masquerade. That's it. So I'll do that, and now I'll just reload that. NFT, NF tables. Okay, so I'll do that packet capture again. TCP dump, TCP port 80, don't resolve it. And now I'll go to that web server again, which was 2.0.0.44. And what do I see now? Well, now I see the source address is 2.0.0.33. That's the IP address of my WAN port on this router here. You can see that, yes? The WAN port that goes out to the internet. So the bottom line is the web server sees my source address as that and not the 10.wop that I had at my home system. So NATing has worked for that. But now I'll show you why it's not a firewall. Because, let's go back here. Back to the good old diagram. All I've done then is set up a little rule in this post routing hook, as you saw in NF tables, on, which was it, the router? I want to find the router. I'll just show you again. So NFT list rule set. All I've done is set up that little rule there on the hook is post routing. So that post routing hook here is where I said, all right, just change your IP address. That's what masquerade means. It means swap your source address to be whatever the WAN is when it's going out of that interface. That's it. So what I'm going to do though, I won't change anything there in the firewall. All I'm going to do now is instigate some packet from the web server over to my host. I'll just use ping. So go to this host here. Okay, so on this computer here, I'll set up a packet capture. So TCP dump, the interface is ETH1 on this, and I'll just look for ICMP without resolving anything. So now go back to the web server and ping that host, and you'll see ping replies here. And obviously you'll see that in the packet capture as well. So the packet capture shows the full end IP addresses with nothing changed. So this packet now started on the web server over here, comes in and it hits all those things, but there's nothing to say don't forward it through to the host on the other side, which in this case is my home host. So no firewall came into it. There was no firewall whatsoever. So NATing isn't filtering, I should say. I say firewall, the whole thing's part of the firewall, but it's not filtering anything. So if I wanted to stop things coming back in, it's like I've shown in other videos, I would have to set up a rule in the forward hook to say, do this, don't do that. And I might make another video in future about NAT, but if I were doing IPv6 then, it would have still NATed to go out. So those, as I said, that rule, sorry, the rules here apply to all iNet, which means IPv4 and IPv6. So that rule would have NATed the IPv6 going out as well. Just keep that in mind. I was going to do a video saying that you can do NAT with IPv6, but I can't be bothered. Just know that it's the same concept. If you're changing the source address on the output interface for either protocol, that's what it'll do. So you can still have NATing in IPv6 if you really want, but it's not a firewall. So if I wanted to make that an actual firewall, what I'd need to do is put something in the forwarding hook. Okay, so here's what I would do if I wanted to stop packets coming back that I didn't start. I would set up a rule in the forwarding hook, okay, which again, right there in the middle, that packets go through if the router's routing them. And I would say, look, if the interface name is ETH1, which is this interface here on my router here, so if the input is coming from that interface and the connection state is established or related, meaning if it's traffic that I started in the first place and it's just the return traffic for that stream, then accept that. If not, what have I done here? If not, input interface name, name, if1, drop it. Okay. So now when I just restart that, I'll do it again. So now I've still got the masquerading, so going from the host to the web server's the same as I had. But now I'm going to ping from the web server again. First of all, before I do it, this is handy that it happened. These are the pings that I still had running from before I just put that rule in on the firewall. So you should remember that existing sessions don't get affected, but if I stop that and I start it again, it won't start because now it's hitting that rule for the first time. And what's happened is it said, okay, you came in here, this is for forwarding, but hey, you came in on the interface that I don't want you coming in on, so stop. That's the firewall, not the NATing. So both of them are part of this net filter architecture here, but it's just important to note that when it comes to the forwarding or the input hook or the output hook, that's when you can set up filters. The others are for NATing. So for the pre-routing hook, the type is NAT. The input hook is a filter, so I can filter what goes through the local processors or not, same as the forwarding and the output, but then I've got the post-routing is type NAT. So I'll just show you that as it stands now, because I've just modified it a minute ago. So that's how the firewall looks now. This bit down here is NATing, which has nothing to do with filtering any traffic. The filter's done here where I say, hey, if you're not returning my own traffic, then drop it. Now in the real world, those 192.168 addresses or 10. whatever addresses shouldn't appear on the internet. Okay, they shouldn't be routable out there. That's why they're for home usage. But that doesn't mean they don't exist. Someone could do something sneaky or tricky or whatever. Or it could just be your return traffic for something someone's trying to craft. Who knows? But NATing won't protect you because even if you had NAT on just by itself, the router will say, oh yeah, that packet's for this network, and I'll just route it. That's all it does, unless it's been told specifically to drop it. I'll just quickly show you something I saw with IPv6 the other day. I had a friend of mine with his IPv6 host, which was just his phone at home. I had him connect to a web server of mine on IPv6 here, and he could connect, and that was good. And I saw his source address. So this was his source address, and he's with Telstra, by the way, which is like our national default kind of internet that a lot of people have. So anyway, he went to my web server. So I thought I'll try and ping his device. And I just pinged it straight away. It was beautiful, right? So there's no firewall whatsoever. He's not into networking at all. He's that guy who had all that crap at his house that I did that video on that time. So he's just got the standard setup, which most people who aren't networkers would have. And I saw where the connection came from, which was his phone, and I could ping it straight away. That means there's no firewall whatsoever for IPv6. So, you still need a firewall. And what happened then, though, I said, just take it off the network. So he took it off his network and it couldn't get there. And he turned it back on again. And I said, do it again. And it had a different address. So it's using a different IPv6 address every time it gets on. That's not really security now, is it? Another friend of mine saw similar. So he set up a web server on his phone at home and then could access it through the internet. So there's no firewall by default. You've really got to look after it yourself. So that means there's a lot of unprotected IPv6 out there, and it's got nothing to do with it not being NATed. It just needs a firewall. So, you know, get a firewall. So it's worth knowing the path that your packets take. This diagram is what I use it for everything when I need to think out loud, even though I pretty much know it off by heart. And it's the same with a Palo Alto. For people who do what you might do is a port forward on your home router. If you're running like a web server at home and you want connections to come from the WAN, you might say, hey, if the destination port is this, send it to this IP address. Well, two things are happening there. First of all, you're changing the pre-routing hook. You're saying change the destination IP, and then you're letting it through a firewall. Now, if you look at a real firewall like a Palo Alto, and you want to set up something similar like that port forwarding for your house, you'll have to do it in two places. You'll have to set up the NAT, which is this part here, the pre-routing hook, and the actual policy to let it through or not. So remember this picture and use it whenever you need to, because it's pretty good. It's what I use, and you just can't go wrong. It's laid out pretty simply there. You can just sort of follow it through and should be able to figure it out. Anyway, that'll do for now. Till next time. Take it how you want.